This is part 5 of the series, The Basics of Geometry. And in this part, since we've talked about segment congruence, we're going to look at an extension of this idea. Here we have a picture which has segment AB, and segment AP is congruent to segment PB. So this segment is congruent to this. That means that the distance from here to here, from A to P, is the same as the distance from P to B. That means that point P is what's known as a midpoint. A midpoint is a point that divides a line segment into two congruent segments. So when you have a picture like this that shows two segments congruent to each other, you know that that point is a midpoint. And because point P is a midpoint of AB, you know that AP is congruent to PB, and the length of AP is equal to the length of PB. Now, point P is the midpoint, so that's a description of what it is. What it does is it breaks the segment into two congruent segments. Something that breaks something into two congruent pieces is known as a bisector. In this case, we're talking about a segment bisector. So this midpoint bisects this segment. And so any object, a line, ray, segment, or plane, that intersects a line at its midpoint is known as a segment bisector. So this line, or we could say ray PD, or ray PC, or segment CD, those are all bisectors of line segment AB. And since line CD is a bisector of segment AB, it passes through point P, which is the midpoint. So bisectors pass through midpoints. A midpoint is a point that divides a segment into two congruent segments. So it's a fairly basic concept, but the idea is an important one. Just like a lot of the things that we've studied so far, you're going to see that the ideas are fairly simple, but they have long-ranging implications that we're going to be using throughout the rest of the course. Now, the next logical question would be, okay, how do I find a midpoint given two endpoints of a segment? Well, that's the topic of our next discussion. So here we have a picture of line segment PQ in a Cartesian plane, or the coordinate plane, and it gives us, we're given the coordinates of these 2 points, and I want to find the midpoint. Well, we don't really have enough information yet up to this point to determine this, so let's start out with some simpler ideas and see if we can work up to the solution to this problem. So let's just assume, for the sake of discussion, that you took 2 tests and your test grades were 75 and 85. And let's further say that you want to determine your test average. Well, you may or may not know that the average of any 2 numbers is the sum of the numbers divided by the number of numbers. So in this case, we have 2 numbers, so we add 75 and 85, and then we divide that result by 2. And that gives us 80. Well, you may be wondering, what has this got to do with anything? Well, let's take a look at this in a little more detail. Let's consider that we have 75 here and 85 here, and our average is 80. Well, let's take a look at the distance between 75 and 80. That's 5 units. And the distance from 80 to 85 is 5 units. Well, if we consider that this is a number line, then we would see that this segment has the same length, 5 units, as this segment, which has the same length, 5 units. So we can clearly see that these 2 segments are congruent based on our definition of congruent segments, which means this has to be the midpoint. So here we have a direct linkage. You can see that the midpoint of a segment is simply the average of the endpoints. So you take your endpoints, add them together, and divide by 2, and that gives you your midpoint. So that's a really basic way of looking at midpoints. Midpoints are simply the average of the endpoints of the segment. So now let's go back to our original problem and see how that helps us. Again, here we have this segment, 3, 3, and 8, 7. We know how to find the midpoint of a segment on a number line, but how is that going to help us here? Well, if you think about it, we actually have two number lines. We're going to have a horizontal one, the distance from here to here, and a vertical one, the distance from here to here. So let's go ahead and draw in two segments here. Let's go out to there about, and then another one from here down. And what we want to do is we want to draw in the coordinates of those 2 points. So this point here is at the same y level as this point. So this y coordinate is going to be 3. And the x coordinate, well, if we look, this point is directly underneath this point. So the x coordinate of this point is going to be the x coordinate of this point. So we can say then that right here, this coordinate is going to be 8, 3. Now the idea is that if we find the midpoint of this segment and the midpoint of this segment, where they intersect is going to be the midpoint of that segment. Fairly logical idea. So the midpoint of this segment, as we just learned, is the average of the endpoints. Well, since this is going horizontally, we're going to average the x coordinates. So we're going to say that 3 plus 8 divided by 2 is the x coordinate of our midpoint. And the average of the endpoints here, we're going to average the y coordinates. So this is going to be 7 plus 3 divided by 2. So this is 3 plus 8, which is 11, divided by 2 is 5.5. And 7 plus 3 is 10, divided by 2, which is 5. So 3, 4, 5. 5.5 is about there. And this is 3, 4, 5, right there. So now if we draw across, we should get an intersection of the 2 points. And there is our intersection. So we would say that this midpoint then is going to be 5.5 and 5. So that's all it is doing midpoint twice. Now we didn't need to go through this whole nonsense here. This is just to show you that we're averaging the x coordinates to find the midpoint in the x direction, averaging the y coordinates to find the average in the y direction, and then joining them up. You could simply just say average the endpoints. 8 plus 3 here divided by 2, and 7 plus 3 divided by 2. And that gives you your result. So just as we did with the midpoint formula, let's go ahead and work some examples to find midpoints of segments. Now we're going to use the same picture here that we used for distance formula. Let's work number 1. We're looking for the midpoint of segment AB. So AB is this. So midpoint then is the average of the endpoints. 7 plus a negative 4 is 7 minus 4 divided by 2, and 8 and 4. 8 plus 4 divided by 2. This gives us 7 minus 4 is 3 divided by 2, which is 1.5. 8 plus 4 is 12 divided by 2, 6. So there's the midpoint for number 1. Number 2, we have BD. So BD is negative 4 and 3. So we have negative 4 plus 3 divided by 2, and 4 and negative 2. So 4 plus negative 2, which is 4 minus 2, divided by 2. Negative 4 plus 3 is negative 1, so that's negative 1/2. Negative 1/2, or 0.5. 4 minus 2 is 2, divided by 2 is 1. Let's move on to 3. CB. So we're looking for this distance here. So negative 4, 4, negative 5, 3. So we have negative 4 plus a negative 5, which is negative 4 minus 5 over 2, and 4, negative 3. 4 plus a negative 3 is 4 minus 3 divided by 2. So negative 4 minus 5 is negative 9. Negative 9 halved is 4.5. 4 minus 3 is 1 divided by 2, so that's 1/2, or 0.5. All right, number 4. Number 4 is dA. So dA, so we have 7, 8, 3, negative 2. 7 plus 3 divided by 2, and 8 minus 2 divided by 2. 7 plus 3 is 10 divided by 2 is 5. 8 minus 2 is 6 divided by 2, 3. And the last one, number 5, is AC. So that's this thing way off over here. So we have 7, negative 5. 7 minus 5 over 2, and 8, negative 3. 8 minus 3 divided by 2. 7 minus 5 is 2, divided by 2 is 1. 8 minus 3 is 5, divided by 2 is 5 halves, or you could write 2.5. Doesn't really matter. Just depends on if you're on a test, just depends on the answer choice you're given. If you're on a homework quiz or something of that nature and you have to fill in the answers, this is perfectly adequate. All right, let's work one more problem that gives us a slight twist to this. In this problem, we're given one endpoint and we're given a midpoint. And we're looking for the other endpoint. So in order to do this, I'm just going to draw a random picture. It doesn't really matter if this reflects the actual problem. It's just our visual representation. So let's say this is negative 2, 5. And our midpoint is 5, 8. We're looking for this other endpoint, xy. Now we know that the midpoint is the average of the endpoints. So the midpoint, 5, is the average of the endpoints, x plus a negative 2, which is x minus 2 divided by 2. So this is our x-coordinate of our other endpoint. This number is the average. 8 is the average of our endpoints, y plus 5. Y plus 5 divided by 2. Now that's all you have to do in these two equations is solve for the variable. So here we have 2 times 5, that's 10, equals x minus 2. Add 2, 12 equals x. Here, multiply by 2, 16 equals y plus 5. Subtract the 5, 11 equals y. So we know that our endpoint here is going to be 12, 11. So just as a quick recap, we solved this using the same midpoint idea. The midpoint x-coordinate is the average of the x-coordinates, x plus x divided by 2. And the midpoint of the y is the average of the y-coordinates. And we will move on to the next topic in the next video.